All right.
So I watched all those shows when I was a kid.
There you go. So your conjugate pair was? All right. So what happens when you multiply these together? What's your what would your number be? What was your answer when you multiply those together? What'd you get, Annie? 49? It was close. It's very close. I can see where you got that from. All right, so we're going to square just to help you out. Remember, in this case here, it's a squared minus b squared. That's how your conjugate works. So we're going to multiply these together, which would give you 4, correct? So then that would be a minus sign, and now we got to take our back number and multiply 3 square root 5 times 3 square root 5. And this is where a lot of people kind of go crazy on this. But I can reorganize. Remember, all of these numbers are actually being multiplied. They're individual numbers, so we can actually change them around. You can move them because PEMDAS says you can move all your multiplication. You can change it whatever order you want. So I could do 3 times 3 and what? Square root 5 times square root 5, correct? So what is 3 times 3? 9, and what's the square root of 5 times square root of 5? Square root of 25, which is just 5. So that gives you a total of what? 45. Now that was a minus sign, Annie. That would make the difference. So it would be what? Negative 41. So you were, I see you had one sign error. That's like a half a point. So good job. All right. So good job on that. Now we are going to rationalize this, which means that we are going to pick our one. We're going to do what we call a well-chosen one. All right. So we're going to pick the one. Well, in this case, I need to get rid of the radical off the bottom. The only way to do that is do a conjugate pair so we can get this answer to be 41. So you're going to multiply by 2 minus 3 square root 5 and 2 minus 3 square root 5, because what's written right here is really the number 1. Okay, we're going to call it the well-chosen one, so that way you can hear that word all the way up through trig, pre-cal, and calculus if you're in here for that long. Those are what we call it here at Dobyns-Bennett. Now, if you go to another school, they're not going to call it well-chosen one. Then they call it magic one, all sorts of different things. Or they just may say, what is your additive identity? Okay. All right, so we got to multiply this together. Well, on the bottom, we know it ends up being a negative 41. On top, I have to multiply this whole thing times this whole thing. Now, Peyton, that is a mess. But we can do it one step at a time, okay? And I think you can get it. So the first thing I'm going to do is I'm going to take the 2 and multiply by that and distribute the 2 there. So what's 2 times 2? 4. See, you already got 1/4 of it done. There's only 4. And then we're going to do 2 times the outside one. What would that be? Ooh, you got halfway. You're already halfway. Okay? So now we got to switch gears and look at the back number right here. This times this one. Ooh, 75%. So that's supposed to be a 3. You said 3. I wrote 5 for whatever reason. All right. And then we got to do it one more time with that one. Now this is minus 2 root 3 times negative 3 square root 5. Again, these are all multiplication. So it's this times this times this times this. So what 2 numbers can you put together? I can multiply this one and this one, right? Which gives you what? 6. And then what about the roots? What happens when you put root 3 times root 5? Root 15. So I get plus 6 root 5. There is your numerator, and there's a minus 41 on the bottom. So, Kevin, what I got to fix? So this is my answer right now, Kevin. Or can we not have in the denominator? Cannot have a negative in the denominator. So what do you have to do with all your signs? Multiply by a negative. So that makes this a positive down on the bottom. That makes this a -4. This makes this a +6. Puts a plus sign right here. And that turns this one into a minus sign right here. So this crazy thing up here is my answer. Yes. It's 15. I wrote 5. There's a 1 right there. Thank you. It's 15. Sorry. There's the answer. All right. So that ugly mess turns into that. Whew. Doesn't seem like I simplified it at all, but it actually is. My wife. I was talking to my wife about this the other day. That we've been practicing this stuff, and she goes, "Oh, we actually did that in calculus just Monday or Tuesday." So they actually manipulated this. So they did something just like that. So if you can get better with this, you get better as you get stronger. We're actually going to be doing this unit next. So the polynomials, the one that we have here, this next problem, that is going to be done in January, okay? We're setting you up for success when we come back after Christmas, all right? So make sure we're still doing this. It still goes with the quadratic unit, but we are doing a roots unit next, which is this stuff, okay? Probably not as insane as we're getting. We're getting on day 5. I'm making them pretty insane on day 5, okay? So we'll kind of slowly build every single day. All right, now, looking at the next one here, as Mary Beth said that we need to factor this, and she found her two factors to be x squared minus 4 minus 16. She took 64, 1 times 64. She wrote down 2 times 32. 3, she was looking to see 3 did not go into it, but 4 did, and she found it to be 16, and she stopped there because she saw that to be what? The 20. Okay? And then she continued to factor it using what? All her conjugate pairs. So she did x plus 2, x minus 2, x plus 4, and x minus 4. And I'm guaranteed she probably already has on her paper the zero product property. You know how to do this, Houchins? It's been a while, so I don't know. Well, kind of. You're solving these solutions. So, negative 2, 0, 2, 0, 4, 0, negative 4, 0. Right, remember, these are roots. The other name is solutions. What else we got? X-intercepts, and we can call them one more thing. We got roots, solutions, intercepts, and yeah, Murray's right. Zeros. All right. How many solutions? Where'd you get that number from, Kevin? It is x to the 4th. Right here tells us. That's the fundamental theorem of algebra. It tells us we have 4 solutions. Y-intercept? F of 0. Well, that would be 0 to the 4th power minus 20, 0 squared plus 64 gives us f of 0 is equal to 64. Anybody know what notation I just used? What that's called, Knox? It's called function notation. We had an in-service yesterday. All right. So we've been doing this anyway, and just that's the name for it. I just need you to be aware of what function notation. That's your input, and this is your output. So you're actually creating a point. You just need to make sure that relationship, you understand the relationship. Okay? So if I want to do like f of 1, then I would plug in 1 And you could plug that in and you can actually get an output, right? So that would give me minus 20 plus 64 and a 1 right here. That gives me negative, positive 44, 45. So f of 1 is equal to 45. So 145 would actually be a point on this graph. Okay. I plugged in 0 for x. You plug in 0 for x to find the y-intercept. It happens to be, Mr. Houchins, in this case here, anytime you're in standard form, it is always that number. Because when I plug in, if I plug in 0 for x, it's going to be that 0, right? It's going to be that back number. This is the function notation, so it's showing you that. Okay? There's your x right there. All right? So make sure you know how to find those. Okay. In behavior. You guys remember in behavior? Moving it to the right and to the left. All right. So what have we been doing with the, how do we find the in behavior? We've been plugging what? We've been plugging infinity into each of your factors, correct? I'm going to make it a little easier on you. And that is what power? Next to what power? Fourth power. So there are 4 infinities. It'd be infinity times infinity times infinity times infinity. And there's no negative in front of that x. So therefore, I would get infinity right here, right? Which means it's going up. Now, if I make it negative infinity 4 times, what would you get? Positive infinity again. So it would also go up. So this is a up for my in behavior. Which means as we go to the right, we go up. As we go left, we go up. So it's going to end up doing something like that. So it's going to start over here and finish over here. Okay? That is the kind of like the path that you're going to follow. All right? As you guys had mentioned earlier, this is a quart. All right? 4 quarters tick. All right? Now, we're going to sketch this. It is an x to the 4th power. If it's an x to the 3rd, it'd be cubic. If it's x squared, it'd be quadratic. If it's an x, it's a line, which is linear. The 5th degree is quintic. The 6th degree, 7th degree, 8th degree, all those are just 6th degree, 7th degree. There's no names for them. All right, label and plot your points. So -2, -4, +2, +4. The only one I actually have to label here is the 64, since the other one are on the points. But it probably is not bad practice to go ahead and label these so they stand out to you. You know your in behavior is going to be up and up. So you start up and finish up. So go ahead and draw through each of the gates and draw a picture. When you get done with that picture, then I want you to label this as an even function, an odd function, or a neither. All right, so this is either even, odd, or neither. Make sure you label which one. Maybe you write all 3 down and circle the one that is correct. So, Houchins, we start up here. We have to go through this gate, turn, and go back up, and then come back down and turn and go back up. So your picture should look something like that. What did you circle? Even, odd, or neither there, Aubrey? Even? Why? It's what? Starts up and finishes up? Kind of, yeah. It's not the real reason. What's the real reason? So remember, these all deal with symmetry, except for neither. Neither just means there's no symmetry at all. So what type of symmetry does this have? Murray says y-axis symmetry. Good job, Cam. Y-axis, Eve. The word Eve kind of splits in half. It can fold together. This is your y-axis right here, Houchins. You can fold it together and it creates a W, right? It's a W. I can cut it in half and do what? Fold it together and be the same. I can take it, really, Houchins, I can take that right there and I can flip it left to right and it would be the same.
So that's how we know.
Correct. Odd functions. How do you know something's odd? Watkins, you know how something is odd? If this one is y-axis symmetry, what's the other symmetry we learn? Origin symmetry or rotational symmetry? And what's special about rotational symmetry? It has to have what? The origin in it. It's got to be original, which means it would have to go from the center. So I don't have this going through 0, 0, so it's not got rotational symmetry. So it's not odd. It is even. It has y-axis symmetry. You got to know the types of symmetry. Okay? So, for instance here, Houchins, if I was looking at this one right here the other day we did, it did something like this. That was off. Because you could take this one, whoops, you can take this one right here and you can rotate it and it would have been, if I drew it right, it would have been right where it was again. Okay? So you rotate it 180 degrees, it'd be back where it was. I can't split that one in half. This one right here, if I draw it, I'll draw another odd one. Here's a different odd one. You can take that and rotate it 180 degrees and be back again. That's odd. I can't cut this one in half, Houchins. Right? I can't fold that to be the same. If I flip this left to right, it's going to... If I take that one right there and I flip it left to right, see? It's upside down. It didn't rotate. It's a rotational symmetry. So that one would have what we call rotational symmetry or an odd function. All right, enough playing around with that. We want to go to our notes.